In this video, I am going to solve this homogeneous differential equation. The equation is dy over dx equals x squared plus 2y squared divided by xy. As you probably remember, the definition of homogeneous differential equation is this: if a differential equation dy over dx could be written as a function of y over x, then it's called a homogeneous differential equation. And another format or another way of defining it is m of xy times dx plus n of xy times dy is equal to 0 is a homogeneous differential equation if the order or degree of m and n are same, given that both m and n are homogeneous differential equations. Okay, so if m and n are homogeneous differential equations both, and they have the same degree, then this differential equation is a homogeneous differential equation. So let's go ahead and solve the original one that we have here, so which is this one. Dy over dx is equal to, I'm going to just take the break it down on the right hand side. Is going to be x squared over xy, that's going to give you x over y, plus 2y squared over xy is going to give you 2 times y over x. The right hand side, this is not exactly in this format, y over x. However, we can convert it into that. So we could just write dy over dx is equal to 1 over y over x plus 2 times y over x. Now I can do the substitution. So let's say v is equal to y over x. Okay, this is how you do solve the homogeneous differential equation. You substitute it, and then you go ahead and convert it into a separable equation, which you will see shortly. So if I simplify it, y is equal to vx, and then dy over dx using the product rule. So I'm just going to write it out. If you use the product rule for derivative, you're going to get v plus x times dv over dx. Now, at this point, I'm going to take this value and take this value and plug it into this equation or substitute these values. So it's going to give me v plus x times dv over dx, which is just dy over dx. dy over dx is equal to v is y over x, so it's going to be on the right hand side 1 over v plus 2 times y over x is 2v. If I subtract v from both sides, I'm going to be left with x dv over dx is equal to 1 over v plus v, which if I simplify it further is going to give me 1 plus v squared over v. And then again, if I were to consider this and simplify it, I'm going to get v dv over 1 plus v squared is equal to dx over x. At this point, I can integrate both sides corresponding to the variables on each side. So left hand side, I'm going to integrate with respect to v. Right hand side, I'm going to integrate with respect to x. And the integral on the left hand side is pretty straightforward. You can just do a substitution, integral v dv over 1 plus v squared. Let's say u is equal to 1 plus v squared, then du over dv is equal to 2v, or 1/2 du is equal to v dv. And I substitute it here, that's going to give me 1/2 integral du over u, which is 1/2 ln of u, absolute value, of course, right? So 1/2 times ln of u is 1 plus v squared. So absolute value of 1 plus v squared. I can technically avoid the absolute value here, assuming that v is a real number. Now the left hand side becomes 1/2 ln of absolute value of 1 plus v squared plus is equal to, right hand side is ln of absolute value of x plus some arbitrary constant. Now I'm gonna just do a little bit of trick here, which is not a trick really. I'm gonna write ln of absolute value of c so that I can combine these two terms and get something interesting. So the left hand side becomes ln of absolute value of square root of 1 plus v square, absolute value, we are considering the positive values here, is equal to ln of a plus ln of b, ln of ab, right? So I could say ln of absolute value of c times x. Now at this point I can go ahead and apply exponential to both sides. So exp and exp, and exponential and logarithmic function, I mean natural log, are inverses of each other, so they're going to cancel each other out. So that's going to give me the following. On the left hand side, square root of 1 plus v square, and on the right hand side, absolute value of cx. Now if I square both sides, I'm gonna get 1 plus v square is equal to absolute value of cx whole square, which I could write technically as c square x square. However, v is y over x, right? So if I substitute that value, it's gonna be 1 plus y square over x square is equal to c square x square. Now I can multiply both sides by x square. That's gonna result in x square plus y square on the left hand side, and on the right hand side is gonna be c square x to the power 4. If I solve for y square, it's gonna give me y square is equal to c square x to the power 4 minus x square, right? Now I can go ahead and simplify it further if I really wanted. So y is gonna be y is equal to y of x is equal to square root of c square x to the power 4 minus x square. And we could put plus and minus sign here, and you have to be careful to deal with the real functions here. So this is how you'd solve this homogeneous differential equation, and finally this is your answer. Okay, this is the solution to this homogeneous differential equation. I hope that this discussion was helpful. Thank you very much.